was an excellent example. Uh, Talking about evaluation, right? Evaluation of causal models. I'm in the field of market mix modeling, and in my field also, people take the shortcut of trying to prove to clients that hey, we have proved that MM is working by giving a picture of the prediction accuracy because it's always easier to prove that, right? You have the ground truth and you have your predicted value, and you can tell the client, look how small the gap is, how close we came to the ground truth. Uh, but the biggest problem in causal inference is that there is no ground truth most often than not. How do we then evaluate, causal methods?
Uh, I don't have an answer for marketing. I think it's very hard. I think one way, I don't know, like we can discuss this. I don't know if we're
For
going to
us?
get anywhere,
Yeah.
but on my field, we have if you can do at least an RCT or a quasi experiment or some sort, or if you have some control on the variable that you're trying to intervene on, I think you can leverage that. And you have basically two ways to evaluate a model. The first way to evaluate a model is that is this model calibrated, meaning does the effect it predicts. So it's still a prediction question, but it's a counterfactual prediction problem, counterfactual prediction
Mhm.
question, right? Does the effect that this model predicts plays out if I do a randomized control trial or if I apply this to production? So I think you can, the way to evaluate the models for causality is to think of, yes, it is still a predictive question, but it's now a counterfactual predictive question, right? So there's stuff like, okay, maybe you can deploy the model to production and you made a counterfactual claim, right? You said, okay, if I apply this treatment to this number of people, this is the effect that I'm going to see. And you go ahead and do that. And if it turns out that you're wrong, then maybe your model is not very good. Of course, that's not the ideal way to do. Ideally, you want to evaluate your model offline, right? With the data that you already have. And if you have some sort of experiments, you can do that. If you have some sort of experience, it becomes a little bit similar to machine learning in the sense that you can hold out a set of data, you can build a model here to predict its effect, and you can validate if the effects it predicted plays out in the other on the other data set. Again, this relies on having RCTs or having quasi experiments of some sort that you can leverage.
Understood. So you're trying to say that there's no particular metric, but it's just the process of doing the experiments and the rigor involved and checking whether the assumptions hold, which kind of, gives you the whole picture whether you have done the causal inference, test properly or not.
Yeah, no, there are metrics. You can get into metrics like there is the area between the Kini curve, below the Kini curve. This is mostly a metric for heterogeneous treatment effects. You can do calibration metrics using linear regression. So basically, you plug your causal prediction into a linear regression model, and you see the parameter should be close to one. If it's close to one, it means that it
Okay.
closely capture your effect. So there are metrics for it. What I'm just trying to get into here is that it's not predict it's not just like machine learning models where you just separate into holdout and training set, because there's something more that you need to have some sort of randomization for those metrics to even make sense. If you don't have any sort of randomization, those metrics, they will be computable but they will mean nothing, like they're meaningless.
Got it.